Good morning everyone, hope you've had a really nice weekend. Today we're going to be understanding that a shape can have the same area and a different perimeter and vice versa. Vice versa is a fancy way for saying and the other way around, so it would be the same perimeter but a different area. To be successful today you're going to use your previous knowledge of 2D shapes and their properties. You're going to be using your knowledge of multiplication and formula, specifically the one for area, height times base, and you're going to be applying your knowledge to solve problems. Today we're going to be investigating rectilinear shapes. A rectilinear shape is a shape where all of its sides meet at right angles. And you can see that I've drawn my right angles on my rectangle here. I've also drawn myself a square. A square's sides all meet at right angles. And sometimes a square can be shown a little bit differently, like this. But it's still a square because its sides are meeting at right angles there. You might need to know that little bit of knowledge later on. So here is a rectilinear shape. Using the ratio of 1 centimetre to 1 square in your books, draw another rectilinear shape that has the same area but a different perimeter. Okay, at this point I need to just make it clear that I have sent you some squared paper. If it's possible to print it off, then great. Then you can use that ratio 1 centimetre to 1 square in your book, and I will show you just how that works in a moment. If you're unable to print off that, that's not a problem. Please don't panic. You can, when you come to draw your shape, then you can just measure the sides with a ruler so it is the right size. Okay. So using the ratio, if you can, if you can't, don't panic. Just use a ruler so that you are drawing it as accurate as possible. So, draw another rectilinear shape. So first of all, I'm going to be underlining rectilinear shape. So my shape has its sides meeting at right angles. I'm not going to be drawing a triangle or a circle here. That has the same area but a different perimeter. And it's asked me to label all the sides and state the perimeter of both. So the first thing I'm going to need to do is, let's write the formula for area. Formula for area is its height times its base. I'm going to shorten area to A now. So what is the height? 4 centimetres. And its base, 8 centimetres. So the area of this shape must be 32 centimetres squared. Area equals 32 centimetres squared. So we want a shape that has the same area but a different perimeter. I'm going to need to know the perimeter of this shape. So perimeter. So I've got 4 centimetres. This side would also be 4 centimetres, so that makes 8. And then I've got 8 centimetres and 8 centimetres, so 8 at 16, 24 centimetres. Remember, perimeter is just centimetres, area is centimetres squared. So I'm going to need the same area. So I need the same area, so it'll be 32 centimetres squared, but a different perimeter. So I can't have my perimeter as 24 centimetres. So let's think about area. Area is height times base, and they're just factors. As you can see on the right hand side, I've already drawn a little margin and written the word factors, because that's what I'm going to be finding. If I find a different factor pair of 32, other than 4 times 8, hopefully that gives me a different perimeter. So let's think of my factors. Let's do this systematically. Let's start with 1. So 1 and 32. 1 times 32. Now let's go to 2 and 16. 3 doesn't work because 10 times 3 is 30. So that wouldn't work. 4 works. 4 and 8. 5, it's not in the 5 times table, it's not in the 6, it's not in the 7 times table, it's in the 8 times table, but it repeats. Now what I need to notice here is I can't use 4 times 8 because my question is 4 times 8. So I'm going to have to use one of the other two. So this is where using the ratio 1 centimetre to 1 square in your books comes in handy. So I'm going to that's the fill, there we go. Sorry, I'm using Mr. Small's board to do today's one. So I'm going to think, right, if I use 2 and 6 then, because I'm trying to draw 1 and 32, I don't have 32 squares going across all down, so I'm going to draw 2 and 16. So let's go down 2 and across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Oh, I'm right on the edge. What I'm going to actually do is I'm going to move that across just so it looks nice. There we go, right, so 2 centimetres there, 16 centimetres there. So now let's just check that the perimeter of my new shape is different. So I'm going to have 2 and 2 is 4, 16 and 16 is 32, so that's going to be 36 centimetres. Are they different? Yes. My area is the same, but my perimeter is different. So that time I've used my factors knowledge to do that. Let's have a look at it the other way around. So again, using the ratio 1 centimetre equals 1 square in your books, draw another rectilinear shape that has the same perimeter this time, but a different area. I'm going to label all sides and I want to state the area of both. So this time let's have a look. Let's try and find the perimeter of this shape. So I've got 3 centimetres, 3 centimetres, 6 centimetres and 6 centimetres. So it's 12 plus 6, 18. So perimeter of this shape will be 18 centimetres. It tells me to find the area of both, so let's find the area of my shape also. So nice and easy, 3 times 6, 18 centimetres squared. So I want the same perimeter but a different area this time. So I'm going to do this, I'm just going to look at the 2 sides, that one and this one. Because all I'm doing to find perimeter is I could add those 2 sides together and then just times them by 2 because they are mirrored on the other side of the shape. So let's find 2 numbers that add together to make what those 2 make. 3 and 6 is 9, so add up to 9. So let's find 2 numbers that add up to 9. So we've got, I'm not going to write and this time because I do that in my factors. 1 and 8, 2 and 7, 3 and 6, 4 and 5. So let's draw. So all I have to do now is let's pick one of these, draw the shape. So because these will all have the same perimeter, and hopefully then I get a different area to 18 centimetres. So let's pick. Well, I can't pick 3 and 6 because that's what the original shape is. So let's pick 4 and 5. So let's go 4 along the top, 5 down going this way. That is a completely different rectilinear shape. So I'm labelling it 4 centimetres, 5 centimetres. My perimeter is 10 add 8, 18, great. So the perimeter is 18 centimetres. That's the same, that's what it tells me to do. And its area is 4 times 5, 20 centimetres squared. Yes, I have a different area. Okay. Now if you are green group, you have some problems where you are going to be finding drawing some new shapes with either the same area or different perimeter or vice versa. You've got a couple of problems where I don't give you the picture of the shape, so it might help drawing it first. And then you have a couple of problems to solve at the end, which is going to get you to think in a slightly different way. If you are watching You I'm Blue group, you have some slightly less problems to start with. I've put in a couple of mastery problems for you to have a go at, and then you have some problems to do at the end as well. Just like normal, all answers are at the bottom, and please do not forget, if you can print off the squared paper, have a go at doing it on there. That can be used for future lessons as well. Just keep printing it off. If you prefer to work on square paper and you don't have any, please do that. If you don't have the facilities to print, then please don't panic. Just measure your sides and draw it accurately as best you can.